really fast, and I know that. It's a whole bunch of nonsense letters if you don't know the names of the amino acids. Okay, so what I want you to do now is go ahead, look back to the normal gene. See if you can find which amino acids now are wrong. Right, so go ahead, start to go through those, flipping back and forth, trying to figure out where it went wrong. And then I would say circle, like we did over here, and just circle that it says the wrong amino acid. All right. I don't know if I got all right. What did you find that's wrong? What's a wrong amino acid? Comparing it to the normal. All right, tell people at your group what's wrong. Comparing it to the normal and looking at what it is now with that insertion. All right, go tell people at your group. You're just looking back and forth. People still copying. Yes. Mm-hmm. Yeah, so what is wrong? Where is the problem? Remember, the amino acids is what really matters. I can still get the same amino acids with different codons. Where does the problem happen? Yeah, so if I'm going along, and I'll use this again of, I'm going to cover it up, right? So this is right, this is right, this is right, this is right. This is where it's wrong, right? So I'm going to circle this one. And when I looked at the substitution one, remember it was only one that was wrong. Ooh. Sorry. It was only one that was wrong, right? Everything else after that should have stayed the same. Oh, sorry. All right. So now, here we go. If I look at this, then comparing it to the normal gene. Where'd it go? Am I on the wrong one? There we go. Comparing it to the normal gene. So I had to go back 2 pages to look at the normal gene. Remember, this one was not the normal gene. That was the substitution one. So I have to go back to the one that says normal. Okay? We're looking at this one that's mutated. Because I see some confusion looking at some people's. Okay? So then everything else after it is where it shows up as being wrong. Because everything else shifts, right? So I've inserted it here, which makes sense why this all of a sudden is a wrong amino acid. Whereas with a point mutation, it was just one, and then everything else was correct. All right? Oops. All right. I'm just going to put that in there. oops, sorry. So it says that this is wrong, so then everything after it has to shift because it's a frame shift. So on the assessment, when you're trying to figure out what kind of mutation is, because that's what you're going to have to do on the assessment, you'll be able to kind of narrow it down quickly. Is it just one amino acid that changed, or was it one and then everything else? Because if it's one and everything else, you know it's either deletion or insertion. If it's just one, you know it's a substitution. So it just affected one amino acid. As opposed to this one, where one is wrong and then everything else stays the same. So it's a frame shift. All right. We good? No? I see people still writing. All righty. Here we go. So now the other kind of frame shift is deletion. Same idea, we're just getting rid of one of the base pairs, or one of the bases. Right, so with a DNA-based deletion, it's one base is removed or deleted. And so then again, same idea, it's going to change all of those codons after. So again, we still have 3 codons and 3 codons. So we have the ATC and we have the GTC. Those are our normal codons. If I have a deletion, I don't get to count the deleted one. So now my first codon is going to be ACG. And it's got to shift over to TCA. And if I had longer sequences, then you would see that every single one shifts after that. And we'll look at that too. All right. All right, so let's look at this. See if you can find where did that deletion happen. Go ahead and look on your own. See if you can figure out where that deletion happened. And Emily, where did I have the wrong one? Oh, so this one should have stayed.
Yeah, I think so.
Oh, this should be an A. Yep. Yeah, so sorry that I put one in wrong. I was trying to go too fast. This should actually be an A in there. So go ahead and change that. I lost my place when I was shifting. It's a lot of letters to type in. All right. See if you go ahead and do this strategy of just moving this along and see if you can figure out where that deletion happened. When you figure out the deletion, give me a thumbs up. You can tell it's a deletion because all of a sudden I have these empty boxes there. So you can tell that it's 3 bases that got deleted. You don't have to go back, looking back in your notes yet, but for now, just figure out, because this is the normal one, and this is the mutated one. So just look to see what's different between these two, because it's not transcribed, it's just showing the normal and the mutated. So you're trying to find, you're comparing these two. Figure out what's deleted in this row compared to this row. Give me a thumbs up if you found it now. There's people still looking. If you didn't find it, keep looking at your paper. It's kind of like a word search. And like I said, try using your pencil or a piece of paper or whatever it is. All right. I'm going to scan across. Tell me to stop when you see it. Stop here. Okay, let's go back. Okay, so right, you can see that it's the C and the A, but you also can see that it didn't shift quite here. It was the whole codon, right? Sometimes that happens. Sometimes it's more than one base that gets deleted. So then in this comparison, from here, this was deleted. It was removed from the sequence. And then what that means is now all of a sudden I can see this frame shift here. So I can see, okay, it's still got all of these. And if I had done that as an A instead of a T, it should have said GAG. So again, change that. GAG, AAG, TCT, and then GCG. All right, and that's why we have like a whole empty codon at the end. Now, because one codon got deleted, that means other things should still be there. That's just going to be all shifted down. And that order of amino acids matters. So let's quickly transcribe. So T goes to A goes to U, C goes to G, G goes to C, T goes to A, C, G, U, G, U, G, U, G, G, A, C, U, C. If you see me making a mistake, please stop me. I don't have a key in front of me. And again, you're going to get more practice doing this, so that's why I'm kind of moving quickly through. So again, you can see that because the DNA had a deletion, that means the RNA has fewer codons as well. All right. Which one? Where? TCT.
Oh yeah, AGA, not AGU.
Oh, sorry. Thank you. See?
Regional expert at transcription and translation.
No, there's a couple that catch me.
Lightning quick.
Yeah. All right. So then we're going to go through those amino acids again really quickly. So let's see. So AUG. Can somebody yell out the codons and then I can find it quicker? Okay, what's the first codon? Matt? CAC. It's going to be histidine. Did you say Mal? Val, thank you. I was like, what's it? CYS. Yep. Gotcha. His. What's that, Lou? LEU. PHE. ARG. Okay. And another ARG. And then stop. Thank you, Regina. All right. So now, again, I'm going to look and compare. Where did it go wrong? So I got to look back at that normal translation. And I'm going to figure out, okay, what got messed up? So again, I can just go through and be like, okay, Matt, that's right. His, that's right. Val, that's right. And then this is where that mistake happened. So now that's wrong, right? So what that means is then all of a sudden things start to shift all the way across, back again. So now you can see that it still is going to have a shift in there. Wait, should this be Lou after Gly? CUC. Let me double check. CUC. Oh, no. Yep, Lou. Sorry. She said it right. I heard it wrong. Okay, so then you can see that everything after it has shifted. Even though it's the same amino acids, it's missing one, which means the protein is wrong. So it shifted in this direction. And an amino acid is lost. So the protein changes. Think if like somebody took away one of my Legos, I'm trying to build something, I can't build the same thing if I'm missing one of the Legos. or putting together a puzzle. If I accidentally drop one of the puzzle pieces on the ground, I can't put the puzzle together. It's not going to work. All right. There's a genetic disorder example of color blindness. We're not going to get into that right now. But when it gets closer to us working on the project, we might come back to it. But for now, we want to go to the next thing. All right. So once you've got this down, if there's stuff that you're missing from previous pages, let me know. But go ahead and take a break if you're all